Okay.
All right. Thanks everyone for joining. Um, Today's talk will be by Dr. Lauren Brock. He is the president and technical advisor of Enroll Inc., providing both lubrication solutions and training worldwide. He began his career back in 1978 as a R&D chemist at Imperial Oil, later joining ExxonMobil, and eventually retiring as global product technical advisor for industrial lubrication. He has lectured on tribology and lubrication practices at several institutions, including University of Toronto, Wisconsin-Madison, University of Edinburgh, uh,
You can't
Tsinghua.
pronounce them. It's
Yeah,
okay.
Tsinghua University in Beijing and ITT in Delhi. Currently, Lauren and colleague Dr. George
Finish.
Staniewski
Yep.
prepare and support the tribology course at Ontario Technical University in Oshawa, at the Lausanne School of Engineering at York University. Lauren has been a member of Society of Tribologists and Lubrication Engineers for 4 decades, serving as the chair of this section and the co-chair of the Education Committee. Lauren is also involved in ASTM, CIM, NLGI, and SAE, and he was the winner of the 2025 STLE Vic Joel Award. Lauren is also the team lead for the ASTM 8112 collaboration, and we'll be talking to you today about the standard. So I'll turn it over to you, Lauren.
Okay, great. Thank you for the introduction. And I guess as the lead of the ASTM standard D112 update, my purpose today is to explain the reason the standard is being expanded, the scope, and a little bit of understanding how the ASTM system works. Often folks hear ASTM and they don't know what that is. So it's a new era for in-service lubricant sampling and industrial applications. We'll talk about why that is true, and we'll understand the expanded scope. And if anyone is interested, this is the time now, as the standard is being enhanced, rewritten, added to, and we don't want to miss anything. So you don't have to be a member of ASTM, and I'll explain that a little further. And if you want to be, that's great. But to belong to the group that is developing the new standard, by all means, let us know. Before delving into topic of oil sampling, which is really what this is about, it's important to explain condition monitoring, what is required for that, what type of sampling is necessary, and also in typically condition monitoring programs out there without a guideline or a standard, things are missed, and the process is missed. And perhaps in and of itself, the process that's set up in a particular industry may not be designed for what is really necessary. Now, we're not going to talk about the whole process of condition monitoring, but we need to understand that this is a key part, feeds into that. Currently, limitations are that there is no standard for sampling for in-service lubricating oils. Nothing is designed to catch wear metals or indications of potential failures. And hello? Yes? Someone want to say something? No? I believe that is enough to set us up for what we need for this journey. At the end, there will be time for questions, and please note them or send them into the chat, which I believe is being monitored. So let's so ASTM D8112, it's the current standard is 8112-22, standing for 2022, which is when it was established. Originally, the standard was for in-service, in-situ sampling in power industry and ancillary equipment. There is no expanded guide covering in-service lubricants across all industries. Oil analysis, as we must remember, has a dual role, and that dual role, we say that, oh, what does that mean? Well, the dual role is primary objective is to monitor the condition of safety-related production-critical systems in operating systems. And the intent is to identify, track the progression of early failure modes, specific early failure modes to a system. Second primary objective is to monitor the condition of the lubricant. So the first is the equipment, the second is the lubricant. Sometimes that gets kind of clouded over or ignored. There is two distinct roles that need to be addressed in your sampling and your testing profile. You need to ensure that the physical and chemical properties remain within the limits necessary to provide the design function of the oil itself. And we must remember that lubricants are an integral part of the tribological system. They're just the same as a bearing or a bolt or a cap or any component in a particular piece of equipment. It's just as important. Lubricant may have a shorter life in some cases than some of the components, but it still is integral. Without it, the rest of the operation doesn't happen. The lubricants interact with all components in the system. That's a key thing to remember. It's collecting information, it's lubricating all components, and in doing so, it brings in information of potential failures, potential changes in the system, and even giving good insight into how to extend the life of a piece of equipment. Both objectives require obtaining an oil sample that can deliver the above message, deliver that information, and be representative of the whole operation. Prolonged exposure to environmental conditions or to more demanding operation can all have a negative impact on the fluid's capacity to perform. Lubricating oils continuously circulating through the system in many cases, and critical contact surfaces collecting the information that you want to know, you want to understand when you're doing condition monitoring, and detect this early signs of specific failure that's developing. It's important to note that due to the wide variety of lubricating equipment designs, users typically focus on lubricant samples and analysis only on safety-related equipment, or those critical to the production itself. Perhaps even that should be reviewed. Understand what you really want, what you're trying to look at. Remove some of those limitations. And again, limitations can be due to suboptimal placement of the sampling ports. Sometimes that in itself, it will never provide what you hope to gain. And representative sample collection without compromise or altering valuable information is key. You collect a sample and you didn't do it correctly or didn't take it from the correct spot, will affect the sample, perhaps negatively, perhaps give an alarm or warning that is not relevant, or perhaps miss an alarm. Oh, at this point, it's key to understand that there is no, and some folks find this, or some people find this very interesting because they, well, I follow a procedure. Yeah, okay, you follow a procedure. 8112, D8112 versus one other practice that is in the STM is called D4057. And for years, industry has had no standard for in-service sampling. And they have relied on this other sampling procedure, then not understand that it was designed for a different purpose at a different place in time. 4057 is a practice defining the manual sampling of petroleum and petroleum products. It's not designed for in situ, in-service sampling of oil that contains wear, debris, and contaminants. So right away, okay, now I've starting off short on my practice, my program. I don't have a standard. This gap has been identified and was identified, I would say, for three years ago. And it's critical to understand the distinction between the two because there is a message that needs to go out there. That D4057 was originally for fresh oil, obtain a representative sample, fresh, unused, it's not just oil, fluid, unused petroleum products for testing and quality verification during the manufacturing process during the custody transfer, and you wanted something that was had a homogeneous picture of the material you were looking at. You wanted to have an accurate volume measurement, and the numbers you often or this collected on that sample had legal and commercial implications. But none of this, you don't see anywhere here that you're collecting a representative sample for in-service monitoring, condition monitoring. So right away, ASTM D8112 is for in-service oils. Obtain a representative sample of an in-service oil. Representative it can often have a broad context, misunderstanding sometimes. So we're going to talk about that a little bit as we go through. Also, a D8112 had a focus of capturing information on equipment condition and fluid health. Again, something that 4057 mandate scope was never required to do. They wasn't interested in the health or the condition the sample was in. They wanted to know what the sample looked like. Does it meet the requirement or the specification or the standard or the C of A that we've agreed to? Not in service. So as we move forward, we're going to talk a little bit more and understand really what that difference is. Hopefully, you'll find it exciting. I know it's in tribology and it's a standard, but it's interesting that here we have an opportunity to do what we haven't been able to do in the past. The takeaway, D8112 is the only in-service sampling standard for condition monitoring program. And it's interesting at this point in time, that standard is for power industry equipment, turbine oil specifically, and ancillary equipment. So there's a gap. We do have a problem. Before we go any further or go much further into this, I'd like to explain a bit more about ASTM and give some insight, because that's key in what we're going to talk about a little bit in a few slides about this particular standard guide. ASTM has, well, it's near 13,000. It may be 13,000 at this point. ASTM standards, they operate globally. I will say this, the name ASTM might have an audience or a reader thinking, oh, this is an American standard. Well, that's where it started. And like ISO and ASTM standards work in concert. They are global standards. They have requirements to fill and provide information and standards for over 150 nations. And they take into account and use the expertise of 30,000 members worldwide. So you can see it's not just United States or America. And it ensures safety, quality, and reliability, constantly responding to new challenges. And that's where we are right now, a new challenge. We're not necessarily the new technology, although some of that is being brought into this particular guide. And it's not a new market. It's actually expanding the market from a very narrow focus to a much broader use. It builds on the principle of voluntary consensus. So no one's forced to be here. No one has a mandate to be there, and gives everyone an opportunity to participate equally. We'll explain how that happens. You're saying, oh, really? No, it's not done for any particular manufacturer or any particular producer. In fact, the system is set up to prevent a bias or undue control by that, which one might expect. You want effective and relevant use across very diverse markets. It helps everyone in this way. You have the consumer, the business, the manufacturer, the innovator, the government, and even just person next door who has an interest, perhaps, in a particular interest. Not all standards are going to focus on oil analysis. We have standards for, even things like garbage bags or window glass, or things like that. Sometimes we'll find that a particular ASTM standard is actually incorporated, written into a contract, a regulation, a code, a law. So around the world, it has very important and broad implications here. The STM publishes the standards. They are the keeper of the standard. They're the keeper also of the process. All stakeholders are involved. A neutral forum, key, remember that, neutral forum, public and private sector cooperation. Several, I was going to say, several members come from areas that aren't even necessarily related in the end. Every member has an equal say. It's true. One vote, one interest, one person. All standards are typically revised on a 5-year cycle. If they're not revised by 8 years, it's withdrawn until a new process is put in place to reinstitute or to reissue a standard to fill that gap. A technical document developed by consensus under certain procedures and regulations is really what we're talking about. This is a kind of a graphic of how an ASTM standard gets created. Number one, someone recognizes a need. We've recognized a need here in the case of 8112 that there was no standard or guide to cover in situ sampling of in-service lubricating fluids. So then once that's identified, it's fed into the STM process, task group convenes, the key stakeholders. Task group would be called a working group. And we have a working group, and I'll show that in a few moments, with 20 members at this point in time. We're happy to make that more, and we'll talk about why. Then the subcommittee, actually, in ASTM, there are different subcommittees that have different responsibilities for different standards and guides. And there's the main committee. DO2 is in petroleum and lubricating products. That's the one we're headed under right now. Then they have subcommittees, and those subcommittees will have experts in certain areas. And then below that would be a task group that's formed that has an interest to develop a standard to fill a gap. ASTM International Committee is a standard review and approval process. Everything is then, once it's completed, the process is then published either online or in print. And that's the user. The end user is the marketplace. So each ASTM standard is giving a unique number. In this particular case, it's 8112. So that is a unique number. And then it's grouped into one of 6 categories and identified the type of standard. There's a standard practice. A practice is a prescriptive instruction on how to do something. Do it this way, this piece of equipment. A guide is what we're talking here, gives options and lets you pick the option in a process that meets the particular industry. And you can see when you're doing a sampling, you might be in a paper machine, you might be in a power plant, you might be in a mine, you could be in many different circumstances. So you have to give options, and we'll find that as we go through D8112. Then there's a standard test method. This is how you're going to do it, and if you're going to claim that this is the result that you got and its validity. There are classifications of type of standards. One that is probably holds an awful lot of legal weight is a specification. A specification is, this is what you do, this is the result, and that is valid legally. And then another one is called terminology. It's a collection of all the terminology used throughout various standards. It's the go-to point to find out what do we mean when we say in situ in this particular case, and then you'll be able to find that. So standard guide, that's what we're talking about here. ASTM standard guide, D112. They're a guideline. It's a collection of information or a list of options, as I said, of varying instructions without specific recommendations saying, well, this one's better than that one, because you have to look at the application. But these are the possible options, and here's their benefits, here's their shortcomings. Decide which one fits best in your application. The STM process. The STM standard process is designed to provide open, and I think I've hinted on this, but I'm going to nail it down here. Open, unbiased, and balanced outcomes. Subcommittee memberships, they have to be a balance. They have to have users, general interest individuals, and that number has to be greater than the producer members. So they keep track of where membership is coming from and what the status of individual members is. And that can change depending on a particular strength of one of the members, one guide or standard. They may be only general interest. In another, they might actually be the producer of a certain test or a certain product. Anyone can participate in the subcommittee meetings and submit comments on the ballots. Anyone. You don't have to be a member of ASTM. Non-member comments before the balloting process and the tabulation of a ballot are treated exactly the same. If someone says certain things should be considered or a certain thing is overkill, then that's taken in, is examined, and a change will be made or a comment noted. Non-members can participate. They can submit ballots, votes, and propose the standards. They bring an outside view. Oftentimes they catch things that otherwise are missed by those that are particularly technical focused long term. Only difference is they're not counted in the official tally. You have to have a certain number of affirmatives, and if there's a negative vote, you have to respond to a negative vote from a member in a certain way, and you have to present that. But the information itself is still as valid. Only STM members vote count in the required ballot returns and majorities. Now, when we're looking at this process, I said we have a subcommittee or we have a task force, and that is a collaborative team. In this case, D8112 is the standard, is D8112-22. I think I have a slide in here where I said 24. I think I was wishfully thinking that this one would be upgraded by then. Usually the dash and the number after that indicates the year that it was actually approved. Sorry, the standard guide for obtaining in-service samples of turbine operation related lubricating fluids. That's D8112-22. Collaborative team, in this case, it's WK88872, or that number. It's made up of 20 representatives and stakeholders. We have ASTM and ISO committee members, technical experts, manufacturers of aircraft and space systems, one particular individual from Boeing, microbial contamination control services, BCA Inc., fluid experts from North America and Europe, myself. I happen to be the lead of this particular working collaboration team. There's Dr. George Stadusky. He has his corporation. Ken Brown of Utility Services Associates, another colleague of ours here in the Toronto section, STLE. Fluid monitoring equipment and components. You got HYDAC. We have JM Canty, two individuals from there. They have equipment for monitoring, measuring, and providing components to that section of the industry. Fluid maintenance, contamination control, and testing equipment. We're looking at manufacturers of test equipment like Amatec, Spectral Scientific, or Fluid Tech International, or Trico Corporation, who make automatic oilers as well as testing equipment and procedures. We have lubricant analysis, testing, and certification members. We have EPT Clean Oil. Gavin Pereira of Kinetrix, another member of the Toronto section, and here we're in Toronto. We have Polaris Labs. We have SGS North America and WearCheck Canada. Bill Fennell working both for the Hamilton section and working with Hamilton section and Toronto section. Again, you're seeing that there's a number of key members from STLE Canada and more specifically Toronto section. And then we have, this falls into the category of someone that actually is a producer. Fluid Sampling Systems and Components, Bernie Hall of Czech Fluid. Bernie has played a key role in the initial development in 2017 or before 2017 in 8112, which is when it was first introduced, and providing equipment so that people understood that you don't just have to have a plug on a drain. You could make multifunction, multi-use of that drain. And again, we have some end users identified here, Brian Johnson and Paul Bowman. There's 20 members. We're happy to make that 21 or 30 or 40 if you have any interest in this, or even a curiosity. We're happy to include you in examination of the draft and where it should go. Maybe what is in there now. We're going to talk a little bit from a higher level. I'm not going to be specific because we only have an hour or less, but we're going to go over the highlights. Initial scope back 3 years ago, or 2.5 years ago, the scope was identified because we had a gap in industry because the standard was limited to power. Therefore, to reinforce this, we needed a primary document for in-service fluid for condition monitoring, expanded to scope all industrial equipment. It's key that, okay, there's the gap. It's in the scope. We're at least headed in the right direction. Then to differentiate, because not everyone, just like I introduced in one of the first slides, there is D4057. Many individuals look at that and say, this is how we standard, or this is how we sample. Weren't aware that this is not what the scope was of 4057. So D8112 has to differentiate itself, has to highlight that it has a strength in this particular area for samples of in-service lubricants. It has to reflect the broader scope of a guide, that being a broader scope indicating that there are options. There's more than one way. As I said, no longer you need a drain plug that's just a plug screwed into a threaded opening. You can actually put a sampling port or sampling device there and collect more valuable information. And therefore, the title should be modified. Initially, the title is specific to power industry and ancillary equipment. And you need to expand the sampling process to include examples of a variety of industrial equipment in a variety, in a broad spectrum of types of industry and systems. And we need to elaborate on the sampling methodology, where the shortcomings are, where the strengths are, why you would or wouldn't use a specific methodology in a particular application. So what's the evolution? You now know the standard. You now understand what the scope was. This standard is currently known as ASTM D8112-22, Standard Guide for obtaining an in-service sample of turbine operation-related lubricating fluid. As you can see, as I said, it's too narrow. It's not aligning with what this standard can do. And the standard has a lot of information already in it. As I said, Bernie Hall and George Danuski worked very hard along with their collaboration team. It's not two individuals, to collect key information that fit the criteria identified here. A strategic move has already been made in this process. The standard was transitioned from Committee DO2 CO1 turbine oils, which was very narrow. And that subcommittee is responsible for only turbine oils, and power-related equipment. So it was recognized, yes, it's true. Have to move it to something that's more relevant to the in-service all application. So DO2 9604 is a subcommittee that handles guidelines for in-service lubricant analysis. So that's the analysis side. It's in service, so we're in the right area. And we've now broadened the scope. And that was actually voted on last year, and it was recognized and it was passed. So first step has happened. The standard is where it should be. A new vision was to establish D8112 as the primary universal document for obtaining in-service fluid samples for condition monitoring across all industrial applications. And that's really where we stand today. We're developing a draft, and we're going to handle that draft and pass it through the various processes, committees, and groups within ASTM, as I've identified earlier. We have a proposed title, but again, this will have to be passed. Just because I say it, George or Ken or anyone else says this title is the right one, has to be voted that it actually is meaningful. It captures the essence. So we're proposing standard guide for sampling in-service lubricating oils and hydraulic fluids in industrial applications. Right away, it's not so narrow. But again, if the working group get together and somebody says, I think it should be expanded or adjusted, we will look at that. Once that draft has been collected and we think we have the right draft, we will pass it back to the subcommittee and they will ballot. So the 20 or 30 members or so of the collaboration team have to have a consensus that we're ready. This draft is ready to go through the process, and it has, we believe it has a chance of passing. You're not going to pass something through all this work until it's ready. After thoroughly reviewing and updating all items in the draft, we then agree on the collaboration team, design the standard itself, and then send it in. So this gives relative numbers. So 20 or 30 people, whatever the collaboration team is, agree, okay, we're ready. Then it's sent to the subcommittee. That's the DO2 9604, which is the new home. And they will do that. Our timeline is in the spring of 2026. So it will go to the subcommittee, and then the subcommittee will vote. That typically could be up to 278, because that's relative membership of the subcommittee. And they will vote. You can see it's getting slightly harder. There's more people looking at it. And if it passes that ballot, then it goes as the draft to the DO2. That's the main committee. And then the main committee look at it, and they would either pass, give an affirmative, or they might send it back with some negative saying this area needs to be adjusted or that area needs to be adjusted. Some of those, we want to look at things carefully and see if they're valid comments. So you have to give reason why you accept or don't accept somebody's negative vote. And then you go back through the system again. DO2 main committee, it can be up to 2,400 people. So we've gone relative numbers here, 20. If we've gone up by 10% in each case, carefully looking at a standard. So by the time it's introduced to the actual, as an ASTM standard in a particular section of the manuals or online, it's been, we believe, thoroughly examined. Just to give an understanding of what's in here, this standard guide has 10 sections. The first few are quite obvious. There's a scope, there's reference documents. This would be either standards, ISO standards, ASTM standards, or other documents that are relevant and referred to within the body of the guide. Then you explain terminology that isn't currently in the ASTM standard for terminology. Those will become part of that, but if they are not specifically in there, then it'll be identified in the document itself. And a summary of the guide, a quick overview, is this, so someone could read it and say, is this relevant to what I'm doing? Talk about the significance of use of the standard. And then we talk about specific requirements of sample port locations, kind of an explanation of where this should be and why it should be there. And then I elaborate on section 7, just so we have an understanding, sample collection hardware requirements. So this is the material that's going to be used in the sample collection from a hardware perspective and supplied by someone. Sample bottles, what kind of sample bottles in a broad sense? Because there's the section 8 actually gets into specifics. Identification of sample ports and tagging, what's required, what's recommended. Permanent sample tubes, as opposed to a flexible hose that you put into an orifice and you don't know where it's really going. You identify where you want that sample to be taken from, and then you put a permanent tube in place so you get consistency. Non-pressurized reservoir. Oh, we have non-pressurized. We also have pressurized. And we look at options to retrofit. Not everyone can start from scratch and go back to the drawing board overall, there are retrofit modules or modifications available in the marketplace. We identify some of them in here. Some of them replace a sight glass or a drain. Others retrofit in through a breather or a vent. Bulk tanks, bulk category is both totes and drums. Drums far surpass the tote, but there are some processes that need to be in place to understand how to sample those reliably and correctly. And then we talk about pressurized pressurized system sampling ports and the requirements behind that. And then there's some other considerations that we need to have in the back of our mind while we're doing this. Fluid compatibility. You don't want to have seals and components of these pieces of hardware or the sample bottle that are dissolved or not compatible. And what the temperature rating is. Not all samples are at room temperature. Corrosion protection and requirements for remote access hose. You don't just grab any old hose off. Well, maybe we do. Maybe we have done that. But the direction is not to just grab any old hose to extend the sampling port. Section 8, as I already alluded, is sample bottles. We get in more details on the sample bottles, and this includes things like vacuum sample bottles. What does that mean? I'll show you a little bit as we go forward, but a bottle that already has a vacuum. So when you plug it into the sampling port, it withdraws that sample. You don't have to pump it into the bottle. So you eliminate some of the errors or contaminations or effects of vacuum sampling. Still key, still important. It's included in here. It's the next item. Vacuum generating device, vacuum pump, vacuum sample thief. And then there's continuous loop sampling, where you have a bypass continuous loop. That section 9 is sampling procedures, some examples, sampling from non-pressurized sample ports using that hand-operated vacuum pump or that bottle with a vacuum sampling bottle. And then again, from a pressurized system, you don't have issues with drawing a sample because there's already pressure in place, but you need to contain that pressure. You need to still manage the amount of purge required before you call it a representative sample, things like that. And then the frequency. How often should you be taking samples to meet your goal or objective? And that's identified and elaborated within the standard. When we talk about elaboration, sampling method and hardware. It's very, very specific. It's not just following the same old procedure you have. It may be good, it may be the right procedure, but you need to examine it, look at other possible methodologies and say, oh, there's better opportunity, or we're just fine. Update the standard provides extensive practical detail to ensure that sample is representative. Critical methodology enhancements, sampling ports, the location for the best place in the system or the closest place, because it's not always possible to put it in exactly the right spot, but at least it tells you where it should be, and then you look for the opportunity, the option. And sometimes you analyze the system, you're going to be building a new piece of equipment, you get the opportunity to build that as a design into the design function or the design of manufacture. And then we identify in the standard between primary, which is the place you take your routine sample all the time for overall. Secondary, where you want specific information on a particular part or area of the lubricant system. And then you have the tertiary. And those points are there only when you're really into troubleshooting. You won't use those routinely because usually there's a lot more samples. As you go from primary to secondary, you increase the number of samples, and to tertiary even more so. Sampling procedures. Your detailed steps are in here. Pre-sampling, what you need to have, your kit, your material you need to get out there, how much you have to purge the oil to make sure you're not looking at oil collecting in a dead leg of a system, or oil that's already too high in contamination. And then you use various sampling methods, drop tube, vacuum pump, pressurized line, as we talked about here. Sampling frequency introduces a data-driven approach. So you look at the past data, you look at the failures of that piece of equipment, you look at how it potentially was initiated, And then you look at on the PF curve and you try to pick the point on the PF curve that is going to be the earliest opportunity to have the best information. Your monitoring schedule. And then you look at the hardware specifications. Is it going to handle the pressure, the temperature, the potential size of particulate that may be generated in that particular operation? If the valve doesn't open enough to catch large particles, then it's acting like a filter. So that doesn't give you a true picture. Non-pressurized systems, including materials, temperatures, rating, corrosion. I mentioned those before. The containers, there's guidance on bottles and the particular, where does PET work, or a high density polyethylene or glass bottle? What are the shortcomings? What are the advantages? How big should the bottle be, and what cleanliness can you expect if you're doing cleanliness, ISO cleanliness count? And then what accessories are available? Covers for the vacuum pump, so that in a dirty, dusty environment, you don't have the pump and the sample bottle, and you're already causing contamination that is not relevant or not representative of really what you want to gather. Or disposable tubing. Notice the word disposable here. Many think that 1/4 inch tubing in a vacuum pump can be used on and on and on. But by doing that, you are really masking or causing errors in your end result. And there are specialized probes that can handle pressure, temperature, dirt, and that's really where you want to go. The next few slides are going to highlight and show images that have actually been created or are being used in this standard to help guide to find the specific spot, whether it be the recommended primary location, secondary location. If it's a non-pressurized loop point compared to a pressurized, then you know which pieces of hardware you're going to need. So we've created some images. This example here, A is a pressure line on the filter side, and we show where it is in the system. In the past, some of the schematic sketches were used, and they're good. They still provide good information, but we've upgraded our technology. ASTM can now publish with colored images like this online. If you're going to go to the hard copy print, this will come out as a grayscale, a high quality grayscale image. So it provides you lots of extra information. When you say, well, the wording up here said this, someone goes and looks here and says, I now understand. They're more a visual person. We recognize that. So you give them something that helps that. Here, sample B. This is on the return line, non-pressurized. It gives you an example of where you can go. And another pressurized option up here with C. Then there are other images that are included here. This one was developed. This actually shows, here's a return line coming back to a reservoir. This pipe, I hope folks can see where my cursor is. This pipe, this line actually captures or can capture samples on the return side. It's not just a random sample from the reservoir. It's going to have more relevant information. What have they done here? They've taken a vent. They still have the vent, a desiccant filter and vent here, but this vent has now had a new attachment that included the permanent specific tube for capturing, as well as a sampling port on the top. A sampling port that doesn't affect or isn't affected by the breather function. The images are there to show that. The schematics that show primary, secondary, tertiary, the number of locations, whether they're pressurized or not pressurized, are shown. Here's one by industry. So here's one for gas turbines. There's hydraulic systems. There's paper machine. There's gear reducers, generators, power generators. So there's images like this. You look at it, you say, okay, I'm looking for the ideal primary location. So it's a circle. I look for all the circles. Now there's a pump there. We look for all the circles in the system, and we find out where we have. Here's one here, and it's got a number 2 on it. 2 refers to, and then we look at the standard here, and we find it's non-pressure sample. So these are also included in the standard to help us be very specific on where we're going to collect that sample. Here's another example. I was talking about gear reducers. This shows a gearbox sampling layout non-pressurized. This one has a kidney loop filtration. That's down here in the lower right. This is taking lubricant out of the system, pumping it through filter and back into the gearbox. So it's doing a bypass cleanup operation. Then we have the general points that can be collected. Here's a place where a sample is taken down here in the lower center, and that you're collecting samples that are likely wear materials coming out of mesh of these gears. These gears are in mesh, and then anything that comes out the other side is used, is exposed lubricant, not used, exposed lubricant that may have valuable information on the wear that's taking place in that interface. There's other places to collect samples, maybe not quite as much information, but you could collect a sample as shown here on the far left, or see, we've got 1, 2, 3 places that you could collect samples in here, whether it's bypass or in system. Whether it's pressurized or non-pressurized is identified in the circle. That's one example. Other images, new images that have been put in here on these ghost images of, here's a collection, a sampling port that has been built into to the top of this particular vent, just like I showed on the other one. Here's the breather, the filter on the breather. Here's the sampling port at the top. Here's a quick connect. This can actually function as a place where an addition of a kidney loop can be added. This tube here keeps equal pressure, both on the sampling side, or sorry, on the venting side and on the bottom intake. But these are in there. They're explained in more detail than we got time for here. Another one is this showing O-rings. This image is provided. This current practice, we have instead of a drain plug, we actually have a sampling port that's put in place here. And that sampling port has a tube, so you're not collecting water and debris from the bottom. It shows where the O-rings, or sorry, the oil rings are. Also shows us that, okay, if we're collecting samples from this location, we're not getting a lot of information from the rolling element bearings, from the bearings themselves, even though they're lubricated with this oil. And yes, some wear metals and things of that nature do return to this sump. But when the ring is splashing the oil in this housing, it's not being specific. So if you need something more specific, it tells you, okay, I'm going to get a generic view of that particular application. Other ones, in situ bypass filtration and the opportunities that are included in there with these portable filter pumps, where they should be connected, that's included. Some images like this explaining the different parts and how do you collect a sample while you're doing this bypass. Another important piece of information. There's some, I talked about some of these multi-port replacements for sight glasses and for vents and for just threaded ports on most systems, getting opportunities. You see this sample, this permanent sample tube, sampling tube on the one side. We have fluid level indicators. We have a place for adding makeup oil or putting bypass filtration in place. And there are images shown in here of real industrial applications. And then there's others showing more modern. They have these lunettes. Well, Lunette is one brand. I'm sorry. There are multiple options, many other companies. So instead of just a flat bullseye sight glass that many of us are aware of, we have a sample port that can be visible from multi angles. It has the capability for sample taken from the top, and this sample port at the top is connected to a permanent sample tube that either collects from in stream in a pitot tube way, or it collects from a particular return spot, depending on where this is placed. This also has a corrosion indicator built in, or possibly, and they have a magnet, so you can actually visualize as they're magnetic ferrous materials being collected, as well as just the sight glass function that it had in the past. And you can do the same thing with the multi-port for vents and breathers. We have a sampling port, we have a breather. These are 3 different companies, 3 different examples. We can see on the backside, there's also a specific permanent sampling tube being attached, and you can collect those samples. In the standard, it also provides examples. Okay, how do we collect it with, say, the probe and sample valve, and what that looks like. Some of the options are available. Here's pressure, non-pressure, sorry, non-pressure, and pressurized. And it has more schematic images showing how that works. Then we have three-way collection for dissolved gas. Oh, that's done and explained. The vacuum pump we're familiar with. Here's an example here on the top right showing a vacuum sample bottle. You would take your tube, you would have your probe on the other end, and then you have this special fitting. You plug it into the bottle. There's reduced opportunity for contamination, but that bottle will actually withdraw in seconds the lubricant. Now we have how much lubricant you need. It's defined in here depending on viscosity grade and what you're trying to do in the sample. So just fill it to the top, depending on the fluid and the grade. And this is using modern technology. We now use QR codes on the sample identification tag. So in conclusion, the expanded, enhanced ASTM D8112, hopefully we can have D8112-26, maybe not, or 27, a significant step forward in reliability in industrial lubrication. It provides a critical guidance on sample location, hardware, procedures needed to collect a truly representative sample. That's both helpful in understanding what's going on there. It's helpful to the oil analysis, third-party oil analysis that you've commissioned to look at your samples. They understand how it was collected. The standard was transitioned to the right subcommittee, and the intent is to ballot, as I said, in the spring of 2026. Adopting this standard will improve the accuracy of oil analysis data, enable better trend analysis, and support more effective, proactive maintenance decisions. Value of a sophisticated, remember this, a value of a sophisticated oil analysis program is entirely dependent on the quality of the samples submitted. The expanded and updated D8112 is the key to unlocking the value identified there. I'm happy to take any questions anybody has. Hello?
Hey, Lauren.
Yeah.
It's not a question, just a comment. I just wanted to say that I'm glad you're presenting this to the STLE in Toronto, and I'm really hoping this does get approved in 2026.
Yep.
You know, this is a great standard. Well, will be a great standard because you know, this is what we've been teaching our customers and in public courses across North America how to do this, and
Exactly.
it doesn't line up with the current ASTM methods or body of knowledge, and of course, being on OMA and OMEX committees, it doesn't line up with the questions. So, you know, I'm very excited to see this released and to start writing some questions for the certification
well, that'll
exams.
be key in rewriting questions and also reteaching, re-educating.
Exactly.
So,
Exactly.
Yeah.
This is what people are educating people on, though. So it's really good to see this alignment coming. So I thank you and your group, Lauren.
Good. Thanks.
Okay, thanks, Lauren. Jeremy, are you going to read the questions from the chat or Payman?
Yeah,
Are there
there's really
questions in the chat? I don't know if I can read them. I don't know where to look. So go ahead, please. Enlighten me.
we have a couple questions really around the containers. I think is really the bottle cleanliness.
Okay, sure.
And then he also asked again, per the method, what is the typical contribution of sampling error to the R&R? And what control limits and validation experiments does the standard prescribe? So I guess if you could just kind of give us an overview on what really around the sampling containers, contamination, test error and stuff is included.
Okay, we're going very specific. That is one area that is in here, as I said, and we talk about what is possible when you purchase a sample bottle, and hopefully you purchase them with the caps on and they're in a sealed bag, and that's the way it's taken to the application. So number one, in a specific type of material, glass is, you're probably never going to get the cleanliness you expect. You're always going to get contamination. If you buy of a specific identified cleanliness rating, then you can expect that as long as you do what I just follow the process that I just identified. Leave the cap on, leave it in its bag exactly as it came, certified, or they're not usually certified. They usually provide a guideline as to the type of cleanliness. Super cleanliness, and it's identified in the standard as to what you can expect, how much contamination might happen. One particle in the whole bottle. That's an exaggeration, but something of that nature is explained in there. Type of polymer that can be used in different systems, and the expectation of cleanliness is in there. I didn't keep a file open so I could show you what those slides are, but if you're interested, let me know and I can send out drafts of what the standard is currently, and you will say, oh, that's good enough, or no, maybe you better delve deeper into here, get a little more information. Is that, and maybe that's a good opportunity. You know, we'd like to have that kind of insight in here if we miss the mark. So if you'd like to see the current draft or the draft in its current, in its current position, I'm happy to send it out. You can send that information to me or to Jeremy or someone at the Toronto section. They'll get it to me and I will send you a copy of the draft as it stands. And then hopefully you can see something and provide some useful information. And maybe you want to join the team. Look forward to that. I hope that gave you an answer. Hello?
Yeah.
Okay.
Yeah. You actually answered the next question at the same time there, so that was great.
What was the next question that I
just about how if he could see the draft and how we go about doing that.
Absolutely. So. It's not a hidden thing. As we said, this is an open process. So it's truly open. You ask, I'll send it to you.
Okay. There's some extra questions about the containers, the materials. Is there anything in the method, I guess, about the actual effect of the error?
Well, it does get into that. Some of that, yes. The answer is yes. Is it? It may not be as in depth as they're expecting. I have courses.
Yeah, it's a very in-depth question, Lauren. Yeah, and I'm wondering if this is specific to EHC systems, because it seems to kind of be focusing on MPC.
Okay.
And I wonder if that's addressed in ASTM 4293 or should be addressed there.
We do talk about fire-resistant phosphate esters and sampling and the type of bottles. That is specifically in the document. So because you have to remember where it came from. It came from the power industry side, so it was already in there. We didn't eliminate any good things that were in there, and we didn't let anything lag behind if there were developments that needed to come up. If you're talking about the testing of it and the result expected, that's not here, but we do talk about the potential errors that could happen. Yeah.
Okay. And finally, one last question for high varnish oils. Does the 8111 or 12 endorse a minimum flush volume or residence time criteria at the sampling valve to ensure representativeness? Yes. Okay.
It identifies the flush volume. It provides some calculations on depending on the piece of equipment you're on, the flow rates, where you're taking sample port, things that were in that question, and it tells you how much do I need to flush before I can get a sample I can trust. So that's in there, yes.
Excellent. Does anyone have any other questions or comments? Okay. All right. Well, I think we can call it here. Thanks everyone for calling in. Thank you, Lauren, so much for your time and your effort, and the development of the guide will be greatly appreciated. So look for our next email for our next one in November. We have the NLGI President Wayne Macklid going to give us a bit of talk about the NLGI and then also a bit about grease manufacture. So thanks everyone, and enjoy the rest of your day.
Take care. Thank you.
Thank you. Thanks, Lauren.
Thank you, Lauren.
Thanks, Lauren. It was great.
Have a good day.
Bye-bye.